Our next section is about simplifying rational expressions. So the first thing that you might be wondering is, what is a rational expression? So you probably have heard the word expression before. Just to review, an expression means that it has no equal sign. We have two types of things in math generally. There's an expression and an equation. The equation has the equal sign, the expression doesn't. So all we're going to be doing is simplifying expressions today. Now, a rational expression is an expression that involves a fraction. So for today, we will actually be simplifying fractions. And I'm going to start you off with a few that are kind of more basic, but still not extremely easy. And then we'll slowly get harder and harder as we go through it. So my first example, I have 3x over 6. So the way that we would do this problem is think about what we would do when we had an actual fraction, 3 over 6. And you would simplify that by dividing both the numerator and the denominator by 3, which would give you 1 over 2. Do not forget to put in that x. Since there's no other x in this, we actually can't do anything with the x. So actually, in the end, our final answer is just going to be x over 2. So our next problem will be a little bit harder. You might have seen ones like this before when we did sections with exponents. If it looks familiar, that's great. If it doesn't look familiar, that's okay, because I'll show you how to do this right now. So the way that we're going to do this problem is we're going to take the numbers and the x's as separate things. We're going to look at them separately. That'll make it easier on you. So first of all, the 4 over 8, we know that that's the same thing as 1/2. So we're going to do that one first. The next thing we have is x to the second over x. There are a few ways to do x to the second over x. I'm going to do it off on the side and then we'll work it out after. So the first way you can do it is rewrite x to the second over x as x to the second over x to the first. You subtract your exponents, which just gives you x to the first. And that's the first way. The second way that you can do it is you can rewrite this as x to the second is x times x. X we just rewrite as x, and you can cancel some stuff out, and you're just left with x, the same thing as you were left with above. So whatever way works best for you, you can use. And for this one, we actually get the exact same answer that we had for the first one. So now number 3 involves something a little bit more complicated with our y's, but not extremely complicated. So we're going to start with the 6 over 9, and then we're going to do the y to the second over y to the third. The easiest way to do this, but kind of the longest way to do this, is to write it out as 6 times y to the second, which is y times y, over 9 times y to the third, which is y times y times y. You're going to do the 6 and the 9 first. That can reduce to 2 over 3. With the y's, you can either think about it as subtracting exponents, or you can think about it as canceling things out. Either way, you would end up, if you subtracted, you would get a y to the negative 1, which would put the y on the bottom. Or if you do it this way, you would just get a plain old y on the bottom in the denominator, and your answer for this is 2 over 3y. If you find another way to do these problems, a lot of people find shortcuts, so you don't have to do it my method because it is long, but if you understand this method, do it. If you don't understand it, or you find another way that's easier, do the way that works best for you. So now we're going to get to the stuff that is completely 100% new. The last stuff I think we did in the exponent section, this stuff is, it's a little harder. but the one I'm giving you actually for 4 is not so bad, and I'll show you why. So this one, I am asking you to simplify it. Now, your first thing that you're probably going to want to do is distribute. Do not do that. So do not distribute. Because when we're simplifying, actually, in order to simplify, we want to have everything in factored form. That will make it easier for us. So we want everything in factored form. So what we're going to do is we actually can cancel out anything that we have in common in the numerator and the denominator. And the thing that we have in common is that 3. That's why we have it in factored form, because if you have things that are in common, you can cancel them out. So now here comes the part that is everybody's favorite place to make a mistake. So the number one mistake I get on my tests and quizzes is people always see this x and this x minus 1, and they try to, I'll show it to you on the side or on the bottom. The favorite thing for people to do is go like that and cross out the x's. Unfortunately, you're not allowed to do that. The reason you can't do that is because our denominator, the x minus 1, is one whole factor. So the x and the 1 are kind of like stuck together. So that's a factor on the bottom. If you want, you can keep parentheses around your final answer. That won't bother me. I won't mark that off. Or you can just rewrite it without parentheses. But the key thing there is you do not cross out your x's, because the factor on the bottom is x minus 1. That's one full thing. So just keep in mind our final answer is this. And actually, next to this thing, I'm going to write that it's wrong, just so you remember that. So here's another kind of similar one to number 4. It's slightly harder, but it's similar. So what you're going to do for this one, once again, you are not going to distribute. Instead of distributing, you are going to simplify your numbers. If you want, you can rewrite 12 as 3 times 4, but I think that's an extra thing. You can just think of it like, okay, we have 4 over 12. We're going to reduce that to 1/3. We also have an x here. We have a factor x minus 2 here. For that one, you are going to want to keep the parentheses around it. And our final answer is just x over 3 times x minus 2. And that's my answer for that one. So here's one that it requires an extra step, but you can actually get this in the same form as the one that you had in the previous example. So what we need to do on this one is we need to factor it first. So we are going to factor it first. You would like to write everything in factored form, then you can start crossing things out. So factor first on this one. When I factor this, the numerator, I unfortunately can't do anything unless you want to write it as 15 times x or 3 times 5, which is kind of a waste of time. So that's not worth doing. However, the denominator, if you look at the stuff I have there, I have a GCF in my 5x and my 10. The GCF of those is 5. So what I can do is I can bring the 5 out front. When I do that, I'm left with x plus 2. So I factored out a GCF there. The next thing I do is similar to what I did on the previous problem, and that is to take the 15 and the 5 and simplify those. When you simplify those, you are going to be left with 3 over 1, or you can just, if you want, you can write it like this. My preferred way of writing it actually is as 3x over x plus 2. And you can't go any further. Remember, you can't cross out your x's. This is my answer for that problem. So one more similar one. I would like you to do this one on your own, please. So for this one, my numerator, I can't change. Denominator, my GCF of those, be careful, it's 4. Be careful, make sure you don't put 2. So when I factor out of 4, I am going to be left with 3x minus 7. From there, I can simplify my numbers, my 2 and my 4, to 1/2. So I get 1x over 2 times 3x minus 7. The only way I'm going to rewrite it is as x over 2 times 3x minus 7. So this next problem is actually, it's kind of fun because it really doesn't require much math at all. So what you can do on this one, actually, first of all, do not FOIL. Do not multiply anything. Don't use the FOIL method. Don't use the distributive property. Do not do anything. Otherwise, you're going to be sad because you have done extra work that didn't do anything. So actually, all you do here is you can cancel out your common factors, which is our x plus 2, x plus 2. Those both go away. When I do that, I'm left with x plus 3 over x minus 2. And that's all I can do. Just another reminder, this is my answer, but I'll remind you again. Similar to the previous thing, if you try to cancel out the x and the x, you cannot do that. That unfortunately is wrong. The reason being that the x plus 3 is a factor, x minus 2 is also a factor. Those are separate factors. You cannot cross the x's out. So the answer is x plus 3 over x minus 2. So my next problem requires a little bit of extra work at the beginning. And our extra work at the beginning is going to be to factor whatever we can. So you're going to factor first. So in order to factor this, you might notice that x squared minus 16 is what we call a difference of squares. And a difference of squares means that we can write it as x plus 4 times x minus 4. Notice how I added parentheses around my bottom factor. You don't have to do it, but I think it's nice to do that. But actually now what you can do is you can cancel out your x plus 4s, and all you're left with is going to be x minus 4. And that's it. So for our next problem, similar thing, we're going to factor first. Notice how there's nothing in the numerator that can be factored. The denominator, however, has a GCF. The GCF is going to be 4. And then I'm left over with x plus 3. So here's another fun problem. The x plus 3s can cancel out. Now, the one important thing that I really want to point out on this is that the 4 stays in the denominator. Since there's nothing left in the numerator, that doesn't mean that we put 0 or that we put 4 or move the 4 around. That means that we actually have a 1 there. So just make sure you are aware of that. So for this one, it's another similar idea. We're going to keep the x minus 2 in the numerator. You can't do anything with that. The denominator, however, is one that we can factor, and we can factor that into 2 binomials. So you are going to factor that by looking for 2 numbers that multiply to 8 and add to -6, and that will be -2 and -4. When you do that, you are then going to cancel things out. Your x minus 4 is in the denominator, and we're going to keep it in the denominator. Do not move it. Do not change it around. Numerator, all you're going to be left with is going to be 1. And that's my answer for that one. So I'm going to give you 2 more, and you can try these 2 on your own. Feel free, once I write them down, to pause them. And if you are not sure how to do it, you can also feel free to just watch me work them out. But I would like you go ahead, pause, and try this. So for number 12, you are going to get 5 times the quantity x minus 3. You factor out your GCF. Denominator, our GCF is 2. You get 2 times the quantity x minus 3. X minus 3 and x minus 3 will cancel. That gives us 5 over 2. For number 13, we are going to come up with two numbers that multiply to 10 and add to negative 7. The numbers that would work there would be minus 5 and minus 2. For our denominator, that's a difference of squares, which means we can write it as x plus 5 times x minus 5. Then we can go through and cancel some stuff out, cancel out our x minus 5s. We're left with x minus 2 over x plus 5.